Hey guys, this is going to be my video for section 6.3, part 2, which deals with another method we have to divide polynomials. Last video, we saw long division, which is also on the screen there on that left-hand side, which is a great method to divide polynomials. It always works, which is probably the best thing about it. But it is a little tedious and cumbersome sometimes, and as you can see from the work there, lots of places we might make a mistake. So today we're going to be covering another method called synthetic division, which works sometimes, but is quicker, is a little slicker, more elegant, and so that's what I'm going to be demonstrating for you today. So as you can see here, and probably the most important note right here for synthetic division, is you can only use it sometimes. You can only use it if the divisor, what we're dividing by, is in the form x minus r. In other words, 1x to the first. That's the biggest takeaway here. We can only use synthetic if we're dividing by something that is 1x to the first. X squareds, we're out of luck. X cubes, we're out of luck. We have to use long division. If we have like 3x to the first, there's a way around it, and I'll show that at the end of the class. But before we can start synthetic division, it has to just be 1x to the first. So what I'm going to do is I have this problem kind of worked out long division-wise on the left. I'm going to work this exact same problem, synthetic division, showing you the process, the setup, the method, and proving that we do get that same result no matter what method we use. So first thing to note, can I use synthetic division? The answer is yes, because it's 1x to the first. In this case, it's actually 1c to the first, but whatever variable it is fine. So as we look at this, what we're going to do is say, okay, in the top row, and this is where it's all new, so pay really close attention to how I'm writing this out to get the setup. In the top row, I am simply going to write all of my coefficients in descending order. So it's written in descending order already. I'm going to say 2c cubes, negative 3c squareds, positive 3c's, and negative 4 is my constant. So all of those coefficients on the top row, I'm going to make a little box over here to the left. And what am I going to put in that box? I'm going to put in that box whatever makes my dividend equal 0. So c minus 2, what would make it equal 0? C equals 2 would make it 0. So I'm going to put a 2 in this little box. And once I have that set up, draw a line leaving a little bit of space under the top row, and we are ready to go. Now here's how synthetic division works, okay? I'm going to try to explain as best I can. We always just bring this first number, in this case the 2, straight down. That's kind of the starting point. After that, anytime we have a number below the line, I'm going to multiply it by what's in the box, 2 times 2, and I'm going to write the result in that next spot above the line. Okay, so if there's a number below, we multiply it by the box and write the result above the line in that next slot over. What do we do with these two numbers? We add them straight down. Negative 3 plus 4 is 1. I'm below the line, so I'm going to multiply by the box. 1 times 2 is 2. Add these straight down. 3 plus 2 is 5. Multiply by my box is 10. Add straight down is 6. And believe it or not, we just divided these two polynomials. The only thing left to do now is to interpret the result. So take a look at what we've got going on here. Originally, this first column represented c cubes, right? From our original problem right over here. And the second column was c squareds, this third column was c's, and this fourth column was just my constant. When we use synthetic division, we are going to knock each degree down by 1. So that 2 that used to represent a c cubed, in my answer it's going to represent c squareds. 2c squareds plus 1c, don't really need to write the 1. I'll keep it in there just so we can see it right now. Plus 5 plus, what does the 6 mean then? The 6 is my remainder, and remember, we just go 6 over whatever we were dividing by, 6 over c minus 2. And that is synthetic division. 2c squared plus 1c plus 5 plus 6 over c minus 2. And you'll notice we got the exact same thing as we did when we did it long division. This is nice. This is, I mean, I would much rather do the way on the right, the synthetic division, than the way on the left. So just a quick recap. Top row, the coefficients that we see in descending order. That's really important. In the box to the left, just whatever would make our divisor equal 0. And then we bring the first number down, and then from that point on, anything on the bottom row gets multiplied by the box, and the result is put above the line. And then anytime we have two numbers on top of each other, we add straight down to get another number below the line. Finally, just to interpret our answer and write it in polynomial form, we just knock everything down by 1 degree. C cubes became c squareds, c squared column became c's. That's our result, okay? Let's try a couple more. So x squared minus 25 divided by x plus 5, and I have a little footnote there saying if a term is missing, fill with a 0. What does that mean? Well, here we have 1x squared, move it out a little bit, we have 1x squared, we have 0 x's, and negative 25 is our constant. And that's what it means saying we need to fill with a 0. We do need that 0 column representing the x's just to keep everything in line. So we got those from those coefficients. My red box, what would make my divisor equal 0? Well, if x plus 5 needs to equal 0, that means x would equal negative 5. So negative 5 goes in the box. Draw our line underneath. And let's start it off. The 1 comes straight down. Now that I'm below the line, multiply by what's in the box. That gives me negative 5. Add straight down is negative 5. Multiply by what's in the box is 25. Add straight down is 0. And this is actually kind of a cool result. We get a 0 there in that last column. That means there's no remainder. This divided perfectly evenly. So I look up at my top row and I said that 1 was the number of x squareds. It's getting knocked down by 1, so x to the first, and then my constant is minus 5. You guys might even recognize that from like factoring or a difference of 2 perfect squares. If we work backwards, x plus 5 times x minus 5 gives us x squared minus 25. But this is synthetic division. This is, again, I like it more than long division, but we can only use it if it's 1x to the first power that we're dividing by. All right, here's a fun one. Y to the 5th plus 32 divided by y plus 2. Go ahead, pause the video for just a second and see if you can get the setup correct. See if you can get all the numbers, the coefficients, and the box and everything all set up the way we need to on your own. When you're ready, unpause it and check back. So I'm gonna assume you've done that and unpaused it now. I'm going to write out the top row. We have 1x to the 5th, 0x to the 4ths, 0x cubed, 0x squareds, 0x to the firsts, and 32. That's my top row, all the coefficients here. What goes in my box? You can probably see that negative 2 is going to go in my box to make that 0, that divisor. And now let's see what happens. Bring the 1 down to start. Times negative 2 is negative 2. Add straight down, 0 plus negative 2 is negative 2. We multiply up, we get 4. Add straight down, multiply up, negative 8. Add straight down, negative 8, multiply up, positive 16. Add straight down, 16, multiply up, negative 32. Add straight down. And we get another one where that last number is 0. That means that no remainder. So what is the answer to this polynomial division problem? Well, let's interpret it. We started with y to the 5ths. We're knocking it down by 1, so we have y to the 4th, and then we just go in order. Minus 2y cubed, oh, that's a y, not an x, plus 4y's minus 8, 4y squared, excuse me, minus 8y's plus 16. So again, the 1 goes to the y to the fourths, the minus 2 goes to the y cubes, 4y squareds, negative 8y's, plus 16. Here we go. That is way quicker and a little less writing and fewer places, I think, to make mistakes than with the long division algorithm. But unfortunately, we can't use this if we're dividing by anything with x squareds or x cubes or anything other than 1x to the first. So that's why we need to know both methods. I got one last problem for you here. And it's on the bottom of the screen, and there's a footnote below it, which is why I'm not scrolling just yet. But if you look at it, 8x to the fourth minus 4x squared plus x plus 4, we're dividing by 2x plus 1. I mentioned at the beginning, there is a way to use synthetic division with this because it's x to the first, and that's the big sticking point. It is just x to the first. There are no squareds or cubes in that divisor. But it's 2x plus 1. We can't really use this algorithm unless it's 1x to the first. So what can we do? Well, we can always, if we want to use synthetic division, just divide both top and bottom by 2. 8x to the fourth becomes 4x to the fourth. Negative 4x squared becomes negative 2x squared. X becomes 1/2 x. 4 becomes 2. But then here's the really important one. 2x became 1x to the first, just x. Now we can use synthetic after we make 1 become 1/2. Okay, will there be fractions? Yes, but let's see how this plays out. We have 4, 0, don't forget that x cubed, 4, 0 x cubes, negative 2x squareds, 1/2 x's, and 2 for our top row. My box, what would make my divisor equal 0? It looks like negative 1/2 now. And let's see what happens. 4 comes straight down. 4 times negative 1/2 is negative 2. 0 plus negative 2 is negative 2, and multiply that by negative 1/2, we get positive 1. Add straight down, we get negative 1. Multiply, we get positive 1/2. Add straight down 1/2 plus 1/2. Half plus a half is just 1. Multiply, we get negative 1/2. Add straight down 2 plus negative 1/2. 2 minus 1/2. 3/2. Okay, so we do have a remainder. It is a fraction. What will that mean for us? Let's take a look. We started with x to the fourth. So 4x cubed minus 2x squared minus x plus 1. And then what is going on with this fraction? Well, that's the remainder we said. And we know how we find the remainder, how we express it in polynomials. We say just put it over whatever we were dividing by. Fraction divided by, I'm going to say this whole thing over 1. Fraction divided by a fraction, let's copy dot flip. So I'm just doing this work over here to the side. 3/2 times 1 over x plus 1/2 equals 3 over 2x, 2 times 1/2 plus 1. Plus 3 over 2x plus 1. And that is my remainder on this problem. So even if we start out with 2x to the first plus 1 in our divisor, we can still use synthetic. We just have to divide everything by 2, make it x to the first. Again, x squareds, x cubes, we're kind of out of luck, but here we were able to use synthetic. And kind of a cool thing, just last comment, you'll notice that the remainder, when we did that copy dot flip, we got 3 over 2x plus 1. That's actually the same original divisor on bottom, 2x plus 1. Not a coincidence. It kind of snaps back to its original form after the synthetic division. This is how it does that, and so it's kind of cool that way. But that is all I want to say for synthetic division for now. We now have 2 methods to divide polynomials. Long division, which never fails, always works. Synthetic division, which is a little bit quicker, I think, a little bit, once you get going with it, a little bit easier. But you can only use it if it's 1x to the first. So we need to know both methods. On your practice problems, you're going to have some where you could use either method. Choose whichever one you want. But there are a few that you have to use long division because we are dividing by an x squared or something. So keep a lookout for those and practice this synthetic division. It's all new. I know this isn't really like anything you've seen before, but hopefully it made sense. If you have questions, write them down and bring them up to me next time we meet. And until then, have a great day.